everyone and welcome to quick summary of the chapter Electricity. I'm your teacher Aditi ma'am and today we'll be covering the whole electricity chapter in quick 10 minutes. So we know this chapter is very important from a numerical point of view, from conceptual point of view, and also for numericals we need to clear our concepts first. So here we are going to revise the whole chapter in just quick 10 minutes for you to revise them before starting off your numericals. Okay, so now I know a lot of you are curious about how I turn on a plug and the fan starts moving, how I turn on a plug and the light starts glowing, right? How does that happen? That happens because of the property of a material, property of the matter, that is charge. It contains charge, it contains positive, negative charges, and that is what we call a property of the matter, charge. Now we know we have two kinds of charges, positive charges and negative charges. We know like charges repel each other, unlike charges attract each other. All about charge. Moving on, if I dhakka that charge, what is dhakka that charge? If I try to move that charge, if I send that charge from a plug to the fan with the help of a wire, that is called motion of a charge. And the motion of charge per unit time, the rate of moving, the rate of motion of positive charges or the rate of flow of positive charges is called current. Now we know direction of current is opposite to the direction of electrons. That's why we said rate of flow of positive charges, and this is measured by ammeter and the SI unit is ampere. Very important formula. Q equals to IT. Q equals to IT. Very important formula. Let's see a basic numerical from here. Electric current of 2 ampere. So a current is given, that is 2 ampere, flows through a wire for 5 minutes. So this is 5 minutes, right? And the total charge that passes through the wire. So we have to find Q. So Q equals to IT. Just remember to convert this minute into seconds. That will be 5 into 60. So that will be 300 seconds. So Q will be 2 is given and the time is 300. So that will be 600 coulomb. Do not forget to write the SI units for your numericals. Okay, let's move on. What next we have is potential difference. Now I have that charge. The amount of work I have to do to bring that charge from this point to this point is called work done. Is called potential difference, right? This is measured by voltmeter. We have this very important formula again. V equals to W by Q. The work done to bring a positive charge from one point to the another is called potential difference. Understood? Its SI unit is volt. SI unit is volt. Understood? Now this is 2 points just. Now a very important point, current flows from high potential to low potential and electron goes from low potential to high potential. Just a very simple, very important point. Understood? The next is Ohm's law. Very important law. Okay, now we have a conductor. I have a conductor. The potential difference between two ends of this conductor, the potential difference between two ends of this metallic conductor is directly proportional to the current flowing through that conductor. That is, V is directly proportional to I. And we know we take out this directly proportional sign and we put a constant in place of it, that is resistance. So V equals to I into R is our Ohm's law. Very important formula, very important concept. And this is the graph, VI graph. It is a linear graph and the slope is given by R, right? Next we have resistance and resistivity. Now resistance is the property of conductor that opposes the flow of charges in it. I know in my conductor charges are flowing, but resistance is the property of that conductor that is stopping the charge to flow, causing a hindrance to its flow, right? So that is resistance. Its SI unit is ohm, and this is again a very important formula, R equals to rho L by A, where rho is resistivity, L is length, A is area of cross section of the conductor. Moving on to resistivity. Resistivity now is the property of that material, of that conductor, that determines how strongly the charge will be opposed. Correct? And we just rearranged this formula and got the formula of resistivity. SI unit for resistivity is ohm meter. For resistance it was just ohm. And we have good conductors like copper, aluminium, they have low resistivity, high conductivity. And insulators, they have high resistivity, low conductivity, like wood, like rubber, like plastic. Okay? Moving on, we have the factors on which the resistance of a conductor depends. We have studied it. The factors are length. See, the formula was what? Formula was rho L divided by A. So the factors is resistivity, the factor is length, and the factor is area of cross section. On area of cross section, resistance depends inversely. If area of cross section increases, resistivity or resistance decreases. Understood? And of course, resistivity, then temperature. For metals, if you increase the temperature, resistivity also increases. But for conductors, for conductors, the resistivity increases when temperature increases. For semiconductors and insulators, the resistance decreases. As you increase the temperature, the charges starts to flow with the speed, and hence the resistivity decreases. Okay. Next is we have combinations of resistors in series, in parallel. When they are connected one after the another, it is called series, just like this in the diagram. And when they are connected between two single points, three resistances are connected, right? That is in parallel. Very important point. In resistances in series, I remains same, right? But voltage is different. On the other hand, in parallel, I is different in each resistance and voltage remains the same. Understood? Clear? Okay. Next we have disadvantages of series combination. I have series combination. What will happen if one combination break, if one resistance breaks, or if one appliance breaks, the whole wire, the whole circuit short circuits, the whole circuit breaks down. Okay? Now, if one device in series fails, all the devices in the series will get disconnected. The second point is in voltage, since voltage is not in parallel, the voltage is not dividing. So, each resistance is getting the same voltage, right? So that they can work independently. Right? So they are getting same amount of current, different amount of current to run, but same amount of voltage. Different devices needs different amount of current to run, which cannot be done in series combination, because in series combination current is same, and in parallel combination voltage is same. So all devices will get same voltage to work. They need same voltage but different current to run. Right? Next one is electric power. Electric power is simply rate of doing work. That means work done upon time. And the most important formula is P equals to V into I, which is always equal to I square R and equal to V square divided by R. Understood? Very easy. Now electric energy. Electric energy is the product of power into time. We studied this power. So this is power into time. So we can write that this is VIT, right? Or I square RT or V square by R into T. Understood? Very basic. Where now 1 kilowatt is 1000 watt into 3600 seconds. Now 1 kilowatt is actually equals to 1 unit, right? One commercial unit that we use in our households. Correct? We have a simple basic numerical. A refrigerator rated 400 watt. So power is 400 watt is given. Operates 8 hours daily. So time is 8 hours. Now, what is the cost of the energy to operate it for 30 days? Now, if it is operating 8 hours daily, so for 30 days it will be 8 hours into 30. right? So electrical energy will be what? We have to calculate electrical energy. Electrical energy will be power into time. Power is 400, but this is what? We have to convert it into kilowatt first. Very important. Convert it into kilowatt first, and then 8 into 30 will be 240, right? And this will be 96000 into 10 raised to power minus 3. That will be 96 kilowatt hour. So energy comes out to be 96 kilowatt hour. Correct? Now we have to just multiply it by 3. So 96 into 3 will be what? 96 into 3 will be the total cost of the energy, and that will be 8 and 288 rupees. Understood? Very easy numerical. Okay. Now next we have some important topic, that is heating effect of electric current. That is my Joule's law of heating. So it says when an electric current passes through a conductor or a device, the conductor becomes hot. Whenever you touch a bulb, it is hot, right? So because electric current is passing through that bulb for a long time and it became hot. This like bulb, fan, iron. So the main formula is I square R T. I square R T, right? And V square by R into T. SI unit is similar to energy, that is Joule. Now alloys, we use alloys when we need to use the elements which we want to get heated, like fuse, like bulb. So we use alloys because they have high resistivity, they don't melt on heating, and they have again high melting point, so they don't melt on heating, right? Next is applications of heating effect of electric current. Simply in bulb we use tungsten filament, right? And filament gets heated, this emits light. The bulbs are usually filled with chemically inactive gas and argon gas to prolong the life of this filament, right? Then electric fuse, a very important topic. This electric fuse protects circuits and appliances in our households. We connect it in series with the rest of the appliances. Its melting point is very low. Now it melts as soon as high current passes through it, thus breaking the circuit and hence protecting our appliances from getting shocked, from getting burned, right? Melts and stops the flow of current. Alloys of aluminium, copper, lead and iron. Correct? Then placed in series with the device. What happens? Large current flows, temperature of fuse increases and it melts, right? It melts and breaks the circuit. Next is join our WhatsApp channel. There is a link in the description. Go join that. We are coming live every day. You don't want to miss. We are solving lots of numericals, lots of MCQs, PYQs for all the subjects. Make sure you join the live and be very active. Okay, and subscribe the channel. That is also a very important step. Go subscribe the channel, like this session for me to bring so many more effective videos for you guys. Okay, tada, bye bye.